In this problem, we're given the 2011 AIME 1 problem 9. Suppose x is in the interval 0 is less than or equal to x is less than or equal to x over pi over 2, and log of base 24 sine of x of 24 cosine of x equals to 3 over 2. Find 24 cotangent squared of x. To do this problem, first of all, we can rewrite the given expression. So this will equal to we can change it from the log form to inverse log, or in other words, exponent form. So this will be given as 24 cubed sine cubed of x would equal to 24 cosine of x. Square both sides to remove the square root. And then you can simplify by dividing by 24 squared. So you'll get 24 times sine cubed of x. This will equal to cosine squared of x. And then we can rewrite cosine squared of x as 1 minus sine squared of x, because we know that sine squared of x plus cosine squared of x is 1. And then simplifying will give us 24 sine cubed of x plus sine squared of x minus 1 equal to 0. And now testing the values using the rational root theorem on this gives that sine of x equals to 1/3 as a root. So now we have two ways to finish this problem, given that sine of x equal to 1/3. The first way to solve this problem would be that since sine x equals to 1/3, we have sine squared of x equals to 1 over 9. So we will have cosine squared of x equals to 1 minus 1 over 9, which is 8 over 9. And then we can use the definition of cotangent squared of x to compute our final answer, because we know that cotangent squared of x equals to cosine squared of x divided by sine squared of x. So then our final answer would be 24 cotangent squared of x equals to 192 just by plugging in the values. The second method is that we can multiply our old equation 24 sine cubed of x equal to cosine squared of x by 24 divided by sine squared of x. This will give us 576 sine of x equal to 24 cotangent squared x. Now we realize that 24 cotangent squared of x equals to 576 sine of x. So our final answer would then be 24 cotangent squared of x equal to 576 divided by 3, which is 192. So that is how you solve this problem using two methods.